Hey class, good afternoon. So let us now come to the continuation of the presentation in fans and blowers. So this time class I will give you example. So in order for you to use the formulas discussed last uh, presentation. Okay class, so let us now consider this problem. A centrifugal fan heaving outlet duct area of 0.84 square meter delivers 1030 cubic meter per minute of standard air. So 15.55 degrees Celsius and 101.325 kilopascal absolute against a static pressure of 305 millimeter water gauge. So the gauge fluid density is 995 kilogram per cubic meter and fan speed is 1500 RPM. So if the brake horsepower input is 100 horsepower, find the static air horsepower. Okay, static air horsepower. So, meaning, if we are going to determine the static air horsepower, we are only going to consider the static head of the fan. Okay, so solution. So, PS or the static power is equals to the gamma. Okay, so the unit weight of the air, and then the discharge, of course, multiplied by the static head. Okay, so getting now the density of air, PB equals to MRT or P over RT. So the given is 101.325 over the gas constant of air, which is 0.287, multiplied by 15.55 plus 273 to make it absolute. Okay, so the density now of air is approximately 1.22 kilogram per cubic meter. So determining now the static head of the pan, so that is the density or the unit weight of the water multiplied by the head of water over the density of air. Okay, so getting now the unit weight of uh, water. Okay, so this was already converted. Okay, so in kilogram per cubic meter. Okay, so that is 0.305 multiplied by 995 over 1.22. So the static head now is 248.75 meters of air. Okay, 75 meters of air. Okay, class. So substituting now. So the values. So that is now the discharge is 1030 over 60 to make it cubic meter per second multiplied by 1.22. So the density of air. So and then changing it to kilonewton per cubic meter and then multiplied by the static head, which is 248.75 multiplied by 1.34 to make it horsepower. Okay? So take note class, 1.34 is a conversion. Okay? So 1.34 horsepower for every kilowatt. Okay? So the answer now, the static horsepower is equals to 68.48 horsepower class. So this is very easy. Okay? So all you have to do is to memorize how you are going to convert the given data and then changing it to English, to SI or whatsoever. So and then substitute the given and then you can easily or you will get easily the answer, of course. Okay? So another class we have here. So the same problem, but we are going to determine the total horsepower. So take note class, for total horsepower, we are going to determine the total head. That is the summation of the static and the velocity head. Okay? So getting now class, the total head, so that is HS plus HB. Or the HS is already given. So this is 248 point something. And then determining the velocity head. And then HB, that is B square over 2G. And then from the given, Q is equals to area times velocity. And then getting now the velocity, that is 20.44 meter per seconds. Okay? And then substituting now to the formula, so the velocity head is 21.29. So total head now is equals to velocity head plus the static head, that is 248.75 plus 21.29, or equivalent to a total of 270.04 meters. And then getting now the total power. So same formula. Okay, so 1030 over 60, and then multiplied by 1.22, 9.81, 270.04, and then 1.34 to make it horsepower divided by 1000. They gave the total power now is 74.34 or 34 horsepower. So very easy class. Okay. So another same problem again. Calculate the static pan efficiency. So uh, it is very easy class. Okay. Static pan efficiency. So, of course, static pan efficiency is equal to static power over the brake power. Okay? So, the static power now is 68.48, and then divided by 100, which is the brake power, multiplied by 100%, the answer is 68.48%. Okay? So, next. So, we have now, for number 4, find the total pan efficiency. Okay, so by this time class, we are going to consider the total power. Okay, so the total pan efficiency, okay, is equals to 74.34 horsepower divided by 100 horsepower is 74.34%. Okay, so very easy class. Okay, so next, we have also here another problem. So find the total air horsepower of an industrial fan that delivers 20,000 cubic feet per minute of air through a 3 feet by 4 feet outlet. Static pressure is 3 inches water gauge. Okay? So air temperature is 70 degrees Fahrenheit and barometric pressure is 29.92 millimeter or inches of mercury. Okay? So the given now class, and then converting it, okay, so 20,000 CFM. So, and then changing feet to meter, okay. So, and then minute to second, so that is 9.44 cubic meter per seconds. Okay, so for the area now of the air passage, so that is equals to 3.65 square meter. Water gauge, changing 3 inches, and then that is equivalent to 0.07621 meter. Okay, changing now 70 degrees Fahrenheit, 2 Kelvin, that is 294 Kelvin. And of course, 29.92 is a standard pressure, so that is equivalent to 101.325 kilopascals. Okay? So, solution now, class. Density of air is equal to P over RT. Substituting values now, 1.325, 0.287, and then 294.1. Okay? The density of air now is 1.2. So, 1.2 class, take note, this is a standard density of air. Okay? So, getting now the velocity. So, that is Q equals to area times velocity. So, velocity now, class, is 2.58 meter per seconds. Okay? So, getting now the total head. So, that is static plus velocity. So, substituting values, the answer now is 63.83 meters. Okay? So, substituting now, using the formula, the air power, of course, the unit weight, discharge multiplied by the total head. Substituting values, 9.44 times 1.2, changing this 1.2 kilogram per cubic meter to kilonewton per cubic meter, and then multiply it by 63.83. The answer now, class, is 10 horsepower. Okay? So, that is the total power. 10 horsepower. Okay? Thank you very much, class. So, that's all about my presentation, class. So, wait for another presentation in this uh, course. Okay? Thank you very much.